Welcome back to my channel. My name is PrachiSharma and today is part 2 of the most important questions of electrolysis. Now, one thing to bring to your notice is that I am getting a lot of requests from you students. Please have a little bit of patience. I can assure you all of the content will come out. All the requested videos will come out. Just give me some time. I am working on the content and it will soon be published on the channel. So stay tuned. Do not lose hope on that. You can trust me that if you're requesting something from me, I will definitely put out the video on that. So let's get started with today's session. All right, students. So let's get started with today's session. All of the questions are visible on the screen. You will get these notes either on the Telegram channel or you can also get them in the description box below. So whatever works for you, you will get the notes easily. Now, the student who reached out that for electrolysis, they are facing issues and they want me to cover all the important portion. So I can assure you, so this video, the video that was posted before this, that was electrolysis important questions part 1. These two, and then there's a test paper on electrolysis. So these three videos are completely based upon the important questions of electrolysis. So that should be sufficient enough for you to target most of the questions. Majority of the questions from electrolysis will be from these ones. So these are the expected questions for your board examination. So let's get started with the first question. So the first question for today says, Mr. Ramu wants to electroplate his keychain with nickel to prevent rusting. And then it says, for this electroplating, name the electrolyte. So what electrolyte will he be using? So he needs to electroplate with nickel. So which electrolyte he will be using? He will be using acidified nickel sulfate solution. Okay. Then name the cathode. So cathode is always something that you're electroplating because at cathode your deposition starts. So at cathode it should be your keychain. Then the next question is name the anode. So your anode will be pure nickel because you're electroplating nickel. Then the next is give the reaction at cathode. So at cathode, as I mentioned, deposition happens. So the ion that goes there will accept electrons and turn itself into the atom. So you will have Ni, nickel, 2 plus 2 electrons that will give you nickel. At anode, you will have the opposite of that. So that would be nickel minus 2 electrons and that will give you nickel 2 plus. So that's for the first question. Let's move to the next one. State one relevant observation for the following. At the anode, when aqueous copper sulfate solution is electrolyzed using copper electrodes. So in this case, you can give any of the observations from the entire experiment. So either you can give that the anode size decreases and cathode size increases. You can give something related to, so you're using copper electrodes, right? So there is no observation in the electrolyte here. So you can just go either with the anode size decreasing, cathode size increasing. So any one of those would work. Now the next question is give appropriate scientific reasons for the following statements. So the first is during electrolysis of molten lead bromide. I think the question is visible now. So let me read it again. Give appropriate scientific reasons for the following statements. So the first is during electrolysis of molten lead bromide, graphite anode is preferred to other electrodes. Why? So the reason is that graphite is chemically inert and it does not participate in the reaction. Therefore, in the electrolysis, graphite anode is preferred. And why doesn't not specifically which area we are trying to avoid the interference of graphite is the bromine vapors, because when you have lead bromide you'll end up getting bromine vapors at the end, and graphite will not interfere or chemically react with bromine. That is the reason we prefer graphite. The next is electrolysis of molten lead bromide is considered to be a redox reaction. The reason is that at cathode you have reduction happening At anode, you have oxidation happening. Both of the reactions are happening simultaneously. That is the reason we can also consider this a redox reaction. Okay, let's move to the next question. The next question is, differentiate between the terms strong electrolyte and electrolyte, stating any two differences. So when we talk about strong electrolyte, you can say that in this the compound completely dissociate itself, and you have the passage of electricity. And when we talk about just electrolyte, so in this case either the compound can be completely dissociated or partially dissociated and has passage of electricity. Then the second one can be that the first one, that is your strong electrolyte, will contain only ions, whereas an electrolyte may have ions and molecules together, because it can be a strong electrolyte, it can be a weak one, or it could be a non-electrolyte at the end. So if you're talking about just electrolyte, it could be strong or weak, any one of those. So either you'll have only ions or you can have ions plus molecules. So both the cases will work. Let's move to the next question. Now students, I am not writing all the answers, I am just discussing with you. So if there is any question you're not able to understand clearly, you can ask that in the comment section. Either you can email me on psclassesicsc@gmail.com, or you can message me on Telegram. I'll be happy to help you with any queries. I'm just trying to make the video short and crisp and go through maximum questions for you. Let's move to the next one. Copy and complete the following table. So this is an important one. I also saw this question in one of the pre-board papers. So let's see. Copy and complete the following table. So the first, you have anode and electrolyte. And what are you working with? You're working with purification of copper. So when you have purification of copper, what will be at anode? Anode will be impure copper. And what will be your electrolyte? So that will be acidified copper sulfate solution. Now let's move to the next one. Write the equation taking place at the anode. So at the anode, as we know, they lose electrons. So at the anode, you will have Cu minus 2 electrons, giving you Cu2 plus. So that is what's happening at anode. Let's move to the next one. 3 different electrolytic cells A, B and C are connected in separate circuits. Electrolytic cell A contains sodium chloride solution. When the circuit is completed, a bulb in the circuit glows brightly. So this is what we are talking about A. So it glows brightly in A. Electrolytic cell B contains acetic acid solution, and in this case the bulb in the circuit glows dimly. So let's move to the B part. So in this case it glows dimly. The third is the electrolytic cell C contains sugar solution and the bulb does not glow. So at C, electrolytic cell C, the bulb does not glow. So this is your observation. Now they are asking, give reasons for your observations. So this is a very, very simple question. So for bulb A, since the bulb is, so for cell A, since the bulb is glowing brightly, this means it is a strong electrolyte. Okay, you have a strong electrolyte there. When we talk about cell B, that is the second case in which you have it glows dimly. This suggests that along with ions, you have molecules also in the solution. This means it's a weak electrolyte. And for the third case, when there is no glow in the bulb, that means there are no ions present in the solution, and this means it's a non-electrolyte. Okay, so this is your answer for this question. Let's move to question number 7. This says, what should be the physical state of lead bromide if it is electrolyzed? So if your lead bromide is electrolyzed, it should be molten or fused state. So molten or fused state. The next is, what particles are present in lead bromide, in pure lead bromide? So the particles that will be present would be your lead ions and bromide ions. So lead and bromide ions. The next is C, that is, write the equations for the reactions which take place at the electrodes using the electrolysis of lead bromide. So we are talking about the reactions here again. So let me write at anode first. Sorry, at cathode. So at cathode, we have acceptance of electrons. So in this case, what will happen? You will have lead 2 plus. It will accept 2 electrons and turn into lead. At anode. So at anode, what would happen? You have 2Br, which will lose 2 electrons and give you 2 nascent bromines. And 2 nascent bromines will combine to give you bromine gas. So this won't be an equal sign. This will be an arrow. Okay. So this gives you bromine gas, Br2. Let's move to question number 8. So the question number 8 says, give one example in each case of a substance which contains ions only, molecules only, and both ions and molecules. So when you talk about ions only, you can give any strong acid. Okay. So if you're talking about ions only, the best example that I would remember would be sodium chloride solution. When you have molecules only, you can have carbon tetrachloride. It's a very common example, and you can see that a lot getting repeated in a lot of questions. Then both ions and molecules can be your acetic acid. Okay, all right, let's move to the next question. Next question is saying, what is meant by the term electrolyte? So what is electrolyte? It's an ionic compound which in fused or molten state can easily transmit electricity, and it dissociates into ions as the reaction proceeds. You can take a look at the proper definition from your book. Let's move to the next one. The next is, the following questions refer to the the second question is, what are the particles present in the compound which is a non-electrolyte? So when you have a non-electrolyte, the particles present will be molecules. The next is, if an electrolyte is described as a strong electrolyte, what does this mean? This means that this particular solution will have a large amount of ions dissociated, which help in passage of electricity. Okay, which helps in a large amount of passage of electricity, and that will be a strong electrolyte. Now the next question is, the following questions refer to the electrolysis of copper sulfate solution with copper electrode. The first is, compare the change in mass of cathode with the change in mass of anode. So of course cathode will start increasing in size and anode will start decreasing in size as the reaction proceeds. Let's move to the next one. What is seen to happen to the color of the copper sulfate solution if platinum electrodes are used? Explain this observation. So if platinum electrodes are used instead of copper electrodes, the color of the solution will slowly starts to fade away. Okay. Now the next question is, what is the practical application of the electrolysis of copper sulfate solution? Briefly describe one such application. So you can use it in electro refining of impure copper. So you can refine impure copper and get pure copper, and then you can explain that. Okay. Let's move to the next one. Then you have define electrolysis again. So the same definition that I mentioned, that you can pick up the definition from the book. If you are not sure about the definition, you can definitely ask that in the comment section. Let's move to the next question. Next is, the following questions related to the electroplating of an article with silver. Now name the electrode formed by the article to be plated. Name the electrode formed by the article to be plated. So when you, that would be cathode, because you always put the article to be plated at cathode. So they said name the electrode. So that would be cathode. The next question is, what ions must be present in the electrolyte? So when you have silver present and you're trying to electroplate an article with silver, then definitely you need what ions must be present? Silver ions must be present. Okay, so the answer is silver ions must be present. Then the next is C, that is, what should be the nature of anode? So anode should be attackable. The nature of the anode should be attackable. That means it should quickly be able to dissociate ions, which can of course end up on your cathode and electroplate your cathode. So that means it should be attackable in nature. The next is, how is the passage of electricity through electrolyte is different from the passage of electricity through a copper wire? So when we talk about electrolyte, the passage of electricity is through the presence of ions in the solution. Whereas when we talk about electricity through copper wire, that is because of presence of electrons in the copper wire. Okay. Now let's move to the next one. Name the product at cathode and anode during the electrolysis of. So this is a very interesting one. So you have to pay attention on this. So when we talk about molten lead bromide, so in that case, so I'm just gonna write C for cathode. So in this case, molten lead bromide. So at cathode you will have lead metal. At anode you will have bromine vapors. Then next is molten sodium chloride. So at cathode you will have sodium metal, and at anode you will have chlorine gas. Then the third is acidified copper sulfate solution with inert electrodes. So when you have inert electrodes, so definitely at cathode you will have copper, at anode you will have oxygen. Then acidulated water with inert electrodes. So acidulated water, at cathode you will have hydrogen, at anode you will have oxygen. Then dilute hydrochloric acid with inert electrodes. In this case your cathode will be hydrogen again, and at anode it would be oxygen. Then the last one is concentrated hydrochloric acid with inert electrodes. In this case your cathode will be hydrogen, and since it's concentrated your anode will be chlorine. Let's move to the next question. The next question is, what will you observe at cathode, at anode, and the third is in electrolyte during the electrolysis of copper sulfate solution with copper electrodes. So for the first case, that is your cathode, your size of the cathode will increase. At anode, your size of the anode will decrease, and the color of the electrolyte will stay the same because you're using copper electrodes. If it was platinum electrodes, the color of the electrolyte will slowly start to fade from blue. Okay. Let's move to question number 13. What is the material for cathode and anode during the electro refining of impure copper? So when you have impure copper, so at cathode you will have pure copper, and at anode you will have impure copper. The next question is, name the metals extracted by electrolysis. So you can have sodium, potassium, magnesium. Okay, so you can name any of them. Then the next is, name the compounds from which these metals are extracted. So these metals are generally extracted from the chlorides. So you'll have to name the compounds. If in the first one you gave the example as sodium, potassium, magnesium, in this case you'll say sodium chloride, magnesium chloride, potassium chloride. Okay. Now the next question is, what is the state of the compounds from which these metals are extracted? So they should be in fused or molten state. Okay. Now let's move to next question, that is question number 15. Name the particles present in. So what are the main particles present in that you have to identify here? So when we talk about sodium chloride solution, so you have sodium chloride, these two ions will be present definitely. Along with that you will have hydrogen ions, you will also have hydroxyl ions, and you will have water molecules. Then in molten sodium chloride, you would have sodium ions and chloride ions. So sodium and chloride ions. Then next is sulfurous acid. So in this case you will have hydrogen ions, you will have hydroxyl ions, you will have sulfite ions. Correct. And then of course you'll have sulfurous acid, so you'll have sulfurous acid molecules. Okay. Then next is carbon tetrachloride. So in carbon tetrachloride you always have just molecules of carbon tetrachloride. So molecules of carbon tetrachloride. Okay. Now let's move to question number 16. Write equations for the reactions taking place at cathode and at anode during the electrolysis of. The first is acidified nickel sulfate solution with nickel electrodes. Okay, let's write the reactions then. So for the first one, I'm talking about the first one. So at cathode, what reactions will take place? You'll have nickel plus 2 electrons giving you nickel. Then at anode, you'll have nickel minus 2 electrons giving you Ni2+. Then you have acidulated water with inert electrodes. In this case, at cathode, you'll have hydrogen plus electron that will give you nascent hydrogen. This nascent hydrogen, when combined with another nascent hydrogen, gives you H2, that is hydrogen gas. At anode, you'll have hydronium ion minus electron, and this will give you OH. Then 2 of OH combines together, so 2 of OH combine together to give you water plus oxygen, and it will give you 2 of water. And actually this should be 4 of hydronium. So 4 of hydronium will combine together to give you 2 molecules of water and 1 molecule of oxygen. Okay. Now let's move on to the next question, that is 17th. Classify the following as strong electrolyte, weak electrolyte and non-electrolyte. So let's start with the first one. Carbonic acid, magnesium hydroxide. Both of them are weak electrolyte. The next is dilute nitric acid and sodium hydroxide. Both of them are strong electrolyte. Then petrol and sugar solution is non-electrolyte. Then moving on to the next question, that is 18th. What change will you observe in the electrolyte during the electrolysis of copper sulfate solution with inert electrodes? So in this case, as I mentioned, if you are using platinum electrodes, the color of the solution will slowly fade away. Okay. Now let's move to the next one. Name the solution which contains only ions or mostly ions. So you just have to name the solution. You don't have to give an example. Okay. So if you have a solution contains only ions or mostly ions, that is a strong electrolyte. Then only molecules is a non-electrolyte. And ions as well as molecules is a weak electrolyte. So you have to make sure that you're reading the question correctly. They are saying name the solution. They are not saying give an example of the solution. Okay, students, let's move on to question number 20th. An aqueous solution containing OH negative, NO3 negative, SO4 minus 2 ions. Name. The first is the ion which will migrate towards anode. So what will migrate towards anode? You'll have OH negative ions migrating towards anode. The product obtained at anode. So the product obtained at anode would be oxygen. Okay. Now next is, what should be the physical state of the following compounds if it is to conduct electricity? So if it is lead bromide, you can have it molten or fused. Then the second is sodium chloride. So either it could be molten or fused or the aqueous solution of sodium chloride. Okay. Now let's move to question number 20th, and I think this is the last question for today. So let's work on this. Now this question says, acidulated water is electrolyzed in Hofmann's voltmeter to liberate 2 gases. In this context, answer the following questions. The first is, name the gases evolved at each electrode. So at cathode you will have hydrogen and at anode you will have oxygen. Then the second is, what is the material used for electrodes? So you are using platinum electrodes here. The third question is, what is the ratio of gases evolved by volume? So hydrogen is to oxygen. Hydrogen is to oxygen will be 2:1 by ratio. Okay, students? Alright, students. So this was it for today's session. We were successfully able to go through all of the questions. If you have any doubts about any particular part of it, you can ask that in the comment section, or as I mentioned, Telegram, or even you can email me. So the next video would be soon coming out. Stay tuned. I will definitely put out all the requested videos on the channel pretty soon. So thank you so much, and I will catch up with you in the next session. Thank you.